Hi everyone, welcome to SKM Academy. Today we are going to see Physics 12th Chapter 1 Example 1.12. So in this question they have given us an early model for an atom considered it to have a positively charged point nucleus of charge Ze surrounded by a uniform density of negative charge up to the radius r. The atom has a hole is neutral. For this model, what is the electric field at the distance r from the nucleus? So in this they have given us an atom has positive point nucleus at the center with the charge plus Ze and around a uniform distribution of negative charge. So total negative charge is written as minus Ze. So according to Gauss law, closed integral of E vector dot ds vector can be written as charge enclosed by epsilon naught. Since the spherical surface, this is spherical surface, electric field is constant, so angle between the electric field and ds will be equal to 0 degree. So this equation can be written as E closed integral ds, which is equal to charge enclosed by epsilon naught, and the angle between electric field and area vector will be equal to 0 degree. So E into 4 pi r square is the area, which is equal to charge enclosed by epsilon naught. So in this we are going to solve for inside the atom what is the electric field, and outside the atom and on the surface what is the electric field. So first we solve for inside the atom, that means r which is lesser than that of r. So in this Gaussian surface which contains of positive nucleus and negative charge, so the volume charge density rho is equal to dq by dv, which can be represented as minus of Zt by the volume is 4 by 3 pi r cube. So total charge enclosed, which is equal to plus Ze plus minus of Zt r cube by r cube. So it can be written as Ze 1 minus of r cube by r cube. So substitute this value in Gauss law. So this is equation number 1 and this is equation number 2. Substitute this value in equation 1. Equation 2 in 1, so that we will get E 4 pi r square, which is equal to Ze 1 minus of r cube by r cube by epsilon naught, which can be written as E is equal to Ze by 4 pi epsilon naught 1 by r square minus r by r cube. So this is the electric field inside the atom. Well, electric field inside the atom. And next we're going to solve for the outside the atom. Outside the atom means R is greater than that of R. Here the positive charge for positive charge is represented as plus ZE, and the negative charge, which is minus Z. So total charge enclosed will be equal to 0. So from Gauss law, E into 4 pi r square, which will be equal to 0. So total electric field will be equal to 0. So electric field outside the atom will be equal to 0. And the next for on the surface. On the surface means R, which is equal to R. So for this, E is equal to ZE by 4 pi epsilon naught 1 by R square minus of R by R cube. So in this equation we are substituting the R is equal to capital R, so that we will get this value. So E is equal to ZE by 4 pi epsilon naught 1 by R square minus 1 by R square, so that this value will get 0. So the total electric field on the surface is also equals to 0. So thank you. We see you in next video.